Got another example problem for you. We've got a neighborhood. This is based on Salt Lake City. Let's say that's my house right there. And I go 9 blocks west. And 1 block in Salt Lake City is 1/8 of a mile. And then I go 3 blocks north. And then, let's say there's a park or something right there, and I can cut through the park. And I go 0.35 miles exactly northeast through this park and end up at my friend's house. And I need to figure out how far, the distance from my friend's house back to my house, and the angle that I'd need to look or shine a laser to get back to my house from there. Well, how do we do this? How do we find the distance we are from there to there and the angle we are from this east line down to where I'd need to shine the laser? First, most basic thing, let's convert these blocks into miles. We could also convert everything to kilometers, but why not miles just for now? And we'll see what happens. So if we convert 9 blocks, well, 1 block is 1/8 of a mile, so I can just say 9/8 of a mile is 1.125 miles. Same thing for the 3 blocks north, that's going to be 3/8 of a mile, or 0.375 miles. What can we do now? We need to find that distance and that angle to get back home. One thing we can do is find the x and y components of each vector and add them up to get that vector. Starting from there, we need to go 9 blocks that way, 3 blocks that way, 0.35 miles that way. Well, the resulting difference between them is going to be this vector plus that vector. The x component of that will be the x component of this plus the x component of this plus the x component of that. This dotted line represents the vector connecting where I end up to my house. And to find the value of that vector, I need to find its x and y components. If I know how I got from here to there to there to there, then I can add up all the x components there, and that will give me the x component of that. And I can add up all the y components of that, and that'll give me the y component of that. You can see that here, that we've got this for our x component of this 9 block thing, and then we subtract off some amount from this last 0.35 miles. These 3 blocks don't add or subtract anything in x. But these 0.35 miles there, they subtract off a little bit in x. So if we take this amount of x minus this amount of x, then we get that. More precisely, we should be saying we're going to take this, and this is going to be minus, because this is going west. I have to go west from here. So I take this is negative 9 blocks, and then we're going to add whatever component, the eastward component of this 0.35 miles is. I'd have some amount of this vector going this way, and some amount going this way. So if I take this amount negatively and add this amount there, because that's how much x this vector has, that's going to give me the x component of this vector. Same for the y. This doesn't contribute any y, but this does. And I can add whatever that component is from this vector, and that's going to give me how much y I have increased. So to look at the x components, I can take the 9 blocks, which is 1.125 miles. I'll make it negative because it's going west, plus 0.35, which is the length of that vector, times the cosine of 45. X component generally is going to be the cosine as long as you're measuring the x like this. If you're measuring, or the angle like that, if you're measuring some other part, then it wouldn't quite work out right. Like if you were measuring from there, then you'd actually have to switch to sine instead of cosine. But this, we're just measuring the angle the normal way, 45 degrees. It's actually not going to make any difference now because we're just at an angle of 45 degrees, but whatever. Make sure that your calculator is in degrees, not radians, and you can calculate out that we must have gone west by 0.8755 miles. To get from here to here would be west going by 0.8775 miles. We can also figure out the y component, which is just going to be this, 0.35 miles plus that component. So 0.375 miles north on that 3-block stretch, plus 0.35 miles, plus the sine of 45. The y component is generally sine, as long as you're measuring like that. And we add them up, and we get 0.6225 miles. So I ended up 0.6225 miles more north than I started out as. How do you figure out the total distance and the angle? We have the x and y components of where I ended up, but how do I convert that, to distance and angle? Well, distance is going to be Pythagorean Theorem. Distance is equal to the square root of x squared plus y squared. We end up having just a triangle right here with this as its hypotenuse. So we can take the y component, the x component, square each of them, add them together, take the square root of the whole thing, and you get the length of that hypotenuse right there. Remember, this x component is this, and that y component is that. To find the angle, well, take the inverse tangent or arctangent of the y component over the x component. Whatever the y thing is, divide that by the x thing, take the inverse tangent of that, make sure that you are in degrees, not radians, and in this case we get negative 35.35 degrees. That's this angle in here. So starting at going directly east, we go negative 35 degrees down to there. Obviously, if we were looking at it from another perspective, well, this is going to have to be positive 35 degrees, but what about this angle? Sometimes you have to add 180 degrees to these things. The negative 35 degrees is a certain perspective of it. But if I'm asking you, what is this angle? Obviously, this angle is definitely not negative 35 degrees. Be very cognizant of that you cannot just say, oh, well, I'm going to just answer negative 35 degrees when I'm asked for this angle. No, that's not going to work out for you. What you need to do is actually calculate what that angle will be. Always draw these things. Anytime you can draw something, draw it, because it'll become a lot clearer once you've drawn it what angles are going to be what. So to find that angle, you'd say, oh, well, my calculator said negative 35 degrees. I can add 180 degrees, and I can get to whatever that angle would be. So always remember to look out for that 180 degree possibility there.